All right. Yeah. Good morning. Yeah. Welcome to another edition of this my YouTube channel. So today we are going to be taking on this particular course, which is maintenance. And the truth is, in today's class, I'm going to be giving you the formula in terms of rotational and linear world motions. Then maybe after that, then you can take any calculation courses under this. The truth is, in physics, the first thing you need to know is mainly the formulas. And once you know the formula, the calculations, how to apply them is very what easy. So what I'll be doing today is that I'll give you all the related formula for this particular course, mainly on rotational and linear world motion. Then after that, you can take some like calculations under them. Now, for this, so we have linear, or you can call it translational. Then while here we have what? Angular. Or you can call it circular. Or rotational. All right. Now, all the parameters we need for this, we have our U, we have our V, then we have our A, then we have our P, we have F, then we have our M, then we also have our U is sitting as W1, V is sitting as W2, then A is sitting as alpha, P is sitting as L, F is sitting as torque, M is sitting as what? Inertia, then X is sitting as S or theta. Then your radius still remains the same and your time still remains the same. Okay, then this is our initial velocity, and this is final velocity. Why this is acceleration, why this represents momentum, like linear momentum. Then this represents force, and this represents mass. Why this represents distance, and this represents radius, and this represents like time. So this represents initial angular velocity, while this represents final angular velocity. This represents angular acceleration. The y this represents angular momentum. Then y this represents torque. This represents moments of inertia. You can also call these moments of a torque. Then why this? Our S represents displacement. Then why this represents revolution. Or you can call it angular position. R represents radius. Then t represents what? T represents time. Now these are all the parameters that we are going to be coming across in this particular course, which is rotational what? Motion. Okay, now I'm going to give you all the related formula relating to this. Then with that, you can take questions under them. So let's see how far we go. Alright, so the first quantity that we are going to take first is that of velocity. That is linear velocity. And the symbol for it is V. And the SI unit is meter per watt per seconds. Now, our V is equals to distance over time. And our V is also equals to theta arrow over time. Our V is also equals to 2 pi arrow over time. So we also have V squared equals to U squared plus 2ax. So we also have V then equals to 8t. Okay, and we also have V equals to square root of ACR, and so on and so forth. So there are so many formulas for velocity. So for the now, we are going to stop here. So let's move down to that of acceleration. Alright, so the next one is acceleration, and the symbol is A, and the SI unit is meter per second square. Now the first one, we have A, AC equals to B squared over R. This one is known as centripetal acceleration. So we also have AT equals to V minus C over T. Okay, this one is known as tangential acceleration. Or you can also write it as AT equals to V over T. That is, when your initial velocity, when it's at rest, and the value is what? 0. It becomes V minus 0 all over T. So we give also V over T. And the next one, we also have A equals to alpha arrow. So alpha there is known as angular acceleration. And you have your what? Your radius. Sometimes you can also take this to be your tangential what? Acceleration, depending on the question and depending on the parameters given in the particular what question. Okay, so we also have A equals to W squared R. So for the acceleration, we are going to stop here for the now. So let's move down to angular speed. So the next one is angular velocity, or you can call it angular speed. And the symbol for it is W, and the SI unit is rad per watt per seconds. Now our W is equals to V over R. Then we also have W, that is AVG, is equals to change in theta over change in time. That is theta 2 minus theta 1 over T2 minus T1. Now this one is known as average angular velocity. So we also have another one, W equals to the theta over the t. Now this is quite different from this. This one is known as instantaneous. Instantaneous angular velocity. Okay, so you can just take note of this formula. We also have W2 equals to alpha t, then alpha t plus W1. How did they go this? From alpha equals to W2 minus W1 all over t. If you cross multiply, it becomes alpha t equals to W2 minus W1. Then make it W2 the square of the formula. If this is crossing over to this side, it becomes W2 equals to alpha t plus W1. Okay, so this is when you are looking for your final angular velocity. Alright, so you can just hold on for this formula. There are more. Okay, so for the night, especially this particular topic, okay, this is what we need. Alright, so we also have so now what normally happens is this. Most of the formula is very easy to get. Okay, you can convert from your linear motion to an angular motion. Now from equation of motion, the first equation of motion, we have A, then equals to V minus U over T. When you are converting it to angular, don't forget A is same thing as alpha, and W2, V is same thing as W2 minus W1 all over time. So we also have another equation of motion. We have V square equals to U square plus 2AX. So this is same thing as W2 square, then equals to W1 square, then plus 2 alpha theta. Okay, then we also have this is another formula for angular velocity. We also have S equals to V plus U over 2, then times T. Then when you are converting it to angular, S is sitting as theta, then equals to, so it becomes W 2 plus W1, then all over 2, then times times T. Then we also have S equals to UT plus half AT square. In converting it to angular, your S becomes theta equals to W1T plus half alpha T square. Okay, you can see this is formula for acceleration, formula for speed or velocity, formula for distance, then theta, then formula for theta is also known as angular displacement. Okay, we also have W, then we also have alpha. Okay, so from here, let me wipe this. Formula for distance, that's x. The SI unit is a meter. Now we have S equals to V plus U all over 2, then times T. So we also have S equals to UT plus half AT squared. We also have S equals to theta R. Then we also have S equals to 2 alpha R. So these are the formula for for distance. We also have formula for displacement or number of revolution. Now the symbol is theta and the SI unit is in what? Radian. This short form for radian is in what? Rad. Now from here, our theta is equals to distance over r. So our theta is also equals to W2 plus W1 all over what? 2. Then times what? Times time. So we also have theta equals to W1T plus half alpha T squared. Okay, so these are the formula for what? For theta. So we also have our change in theta is equals to theta 2 then minus theta 1. So these are the formula for what? For theta. Okay, so right now we can move to the next phase and take some questions relating to all these formula. Then let's see how far we can go today. All right. Okay, so these are all the formula in relating to this particular words topic, that is rotational words motion. Now this time around we went ahead to take some questions under this formula, so let's see how to apply them. All right.